today we are going to discuss about the resistance and how to find the value from those representations. As in our earlier lectures also, we have discussed about the 4-band resistance, how to calculate by the help of different color codes. Okay, let's revise that and we will move towards various kind of other SMD components also, which are also known as surface mount resistors or surface mount devices. Let's start from this resistor labels conversion calculator. If somewhere we have seen K means 10 raised to power 3, M is equal to 10 raised to power 6, or we can say that it is mega, and 1 mega ohm is equal to 1 and 6 zeros ahead. Okay. Or we can write it like 10 raised to power 6 ohm. 1 kilo ohm can be written as 10 raised to power 3 ohm. For example, if it is 3.3 kilo ohm, we can write it like multiplying with this number 3.3 with the 1000. Then we can write it like 3300 ohms or 3.3 into 10 raised to power 3 ohm. And likewise for mega ohms. Okay, and here we have the chart, similar chart as we have already seen. Color, if it is black, brown, red, orange, etc. till this white, we have these significant figure numbers used to find the value of the resistances. And if it is in multiplying unit or third number or third band in this resistance, then we have to multiply that value with that 10 raised to power 1, 10 raised to power 0, 10 raised to power 8, 10 raised to power 9, etc. Okay. Now we move towards this 4-band resistance calculation. If this is a resistor from this point, which is towards left side, from the left side, first band is of red color. If this is first band, then this is the first digit. Then second band, we have the second digit, which is black in color, and third band should be a multiplier. And for what? For 4-band resistors. And last band, which is of gold color, is used for a tolerance. For example, अभी अगर हम यहाँ से कॉपी करते हैं इनके कलर कोड्स को and we try to make or find out the value of the particular example of this resistor, then first is red. Red means 2. Okay, from this point, if it is 2, then make it as a first digit 2. Second one color is black of this band, and black is 0. Okay, then put it 0. And third band of orange color will be used as a multiplier, that is multiply by orange. Orange number is 3. That means it should be multiply by 10 raised to power 3, not we are doing right 3. Instead of that, we have to multiply that with the 10 raised to power 3 for orange. And last band is for gold. And gold is having this 5% tolerance. Okay, so we can write it like 23. 10 raised to power 3 this can be written as K, and this is 20 kilo ohm plus minus 5%. This is for 4-band. Most commonly, you have also done the examples in your previous lectures. Now we will move on to the next 5-band resistor. Somewhere you also find in the electronic circuit that you can be confused whether or how to find the value of resistance when there are 5 bands instead of 4 bands. Let's discuss how to tackle those 5-band resistor codes. First is blue color, and it is again a first digit. Second color is purple, and it is again treated as a second digit. And green is third band, where in above example, third band is treated as multiplier, but here if it is a 5 band, then we have to take this third band as a third digit, and fourth band is treated as multiplier, right? Then last one is of brown color, and it is should be plus minus 1% for the tolerance. Then we can write it, and by using this color code scheme, blue is of 6 digit, number 6, put it 6, then purple is from this is 7, and then green is of your 5, put it 5, and multiply by the fourth band value or color, which is brown, and brown is of 10 is 10, or 10 is power 1. Okay, then we put it multiply by 10, that means 6750 ohm, and for last band plus minus 1%, which is a brown in color for tolerance, right? So wherever there are 5 bands in the resistance, then you have to apply this concept for finding out the value of the resistance, right? There is another example. Yellow one is first color, second band is purple, and third band is green. It is 5 band resistor, readability, then 47, and third one is multiplier. Second one, fourth one is tolerance, and last one is reliability. Sorry, reliability. In brown is used as a reliability. And reliability means what? This is 4, 7 for first two digits. 4 is for yellow, and 7 is for purple. And third multiplier of band is for green. Green means 5, and 5 is this, and plus minus brown is for reliability divided by 1000 hours means the use of this resistance as a reliable resistance without changing its internal resistance varying much greater than this silver tolerance power, then we have to use, we can say that after 1000 hours of working of this resistance in a circuit, it might get changed with plus minus 1% reliability. That means we can lose the reliability of this resistance to be offered the value of 4.7 mega ohm plus minus 10% after this resistor being used for 1000 hours, and reliability is given by this format. Brown is for 1, and red is red in color, last one is 10.1, it is orange 0.01, yellow is 0.001, right? Next we will move towards the 6 band resistor code. We have the 6 different color bands over the resistors, and what we have to follow. First digit from the left hand side, second digit, color band is purple and red, and third digit will be blue, and we have to use this 276 by finding out the values from the chart of resistor code, color code, and then fourth one is of a multiplier band, which is black, that means 1. Okay, 10 is to the power 0 is the multiplier, that means 10 is to the power 0 will be 1. For this brown color, for this fifth band, brown is used for tolerance, and this last one is red, is used for temperature coefficient. What this temperature coefficient means? If the temperature increases, then the internal value or internal property of those atoms used or material used in this resistance will be affected by the parts per million, which is 50 for this red in color. This can be used when we take care of about 6 bands of resistor. Somewhere you can find 4 color band, somewhere you will find 5 color resistor codes, or somewhere you will have this 6 color band. Now, in today's scenario, what we have in the electronic circuit, we shrink the value or we shrink the packaging. These are the very large, or we can see with the help of our naked eyes, and somewhere in your motherboards or advanced electronic circuits, we do not use these kind of resistance which is in cylindrical form, because it is using the much larger space as compared to the surface mount resistor boards or resistors. Then why we are using these surface mount resistors? Because to reduce the size of the PCB, we require a small circuit. Suppose if we have a Apple wristwatch, then we can't use this much size of a resistor, which is 4 band, 5 band, and 6 band resistor. So because we have to make the electronics light in weight and small in size, so for that purpose we designed, or we have come out with another kind of a resistance, which is known as a flat surface. Surface means top of your table, and that is a surface, and mount means we have to solder it. We have to join that on the surface of the PCB with the help of soldering iron and solder on the surface itself. That means their leads or their legs do not come outside on the back of the PCB. Okay. Where in the 4 band resistor there are 2 leads which must be goes inside the PCB holes, 2 holes, and these are also known as through holes component, 4 band, 5 band, and 6 band resistor. But this surface mount resistor do not require pulling or drilling through the PCB board, printed circuit board, to be used. Okay. That means we have to join those resistance on the surface itself. Now, if you might see in the electronic circuit, or specifically if we are talking about Diwali lights, and there are a changeover or a driver in itself for those flash lights or flash LED lights. If you have gone or seen somewhere like that, in those small PCB circuits, you will have the black spot and connected them to sides, and then you might see what is that. These are the resistances. Okay, and there are numbers written on the surface of those components, and there there is meaning behind these numbers. So let's start how to find the values of those resistances. There are 3-digit labels. Okay, generally we find the 3-digit labels. Or if you have the LED strip lights, then you can have one LED, and from towards left or right you might find the small black color component, and very tiny component over which we can see these 4 or 3 numbers. And if you have those strips in your phone of LED, you can find out the value of those by using a multimeter, or otherwise you can read out those codes 101, 105, whatever is written on those, and you can find the value of or meaning of those codes. So first 2 digits let's start how to read it. The first two digits represent the significant figures, and last digit specify the multiplier. Okay. For example, 10. That means these two first two digits from the left hand side are used as a digits. That means 10, and last one is used as a multiplier. That means 10 raised to the power 1. That means 10 itself. 10 multiplied by 10 will be a 100 value. That means if somewhere you find that on these surface mount components which are resistances, then if there is 105, that means 10 is for two first and second digits, and multiplier of 5, that means 10 is to the power 5. That means you can write it like this: 50 add 10, that means 1 mega ohm, right? This 105 is treated as 1 mega ohm resistance. It's a very large value. Okay, 224. If it is there, that means you can write it like this: 220 kilo ohm. You can simply read it like this. And if there are written in mid at first place or if at last place on these three digits, then you can find out that wherever there is this R is written, that is represented as point or decimal. That means 1.0, that means 1 ohm. If 22R means 22 ohm, 22.0, right? If this is R10, that means 0.10 ohm, and 0.1 ohm is the value of the resistance.